Hey everybody. Well, today I am in the Armand Bayou Nature Center, which is southeast of Houston, um, and I want to talk to you a little bit about wetlands and the importance of wetlands when we talk about water quality and flooding and aquatic habitat as part of that. So the Armand Bayou Nature Center is a large complex, several hundred acres of land that includes what we refer to as a mosaic or a complex of different habitat types that includes coastal prairie, it includes coastal bottomland forest or riparian forest in this particular instance, and also has emergent wetlands along the bayou itself. Now, truth be told, there are wetlands embedded essentially through most of this property. Um, this area is located along a floodplain that drains into Armand Bayou, but it doesn't drain necessarily in the traditional sense. So instead of being a network of streams that drain into Armand Bayou and eventually out to Galveston Bay, in fact, the wetlands that are embedded on most of the land surrounding Armand Bayou are what we would refer to as pothole type wetlands, meaning they are shallow depressions in the land surface that will catch and hold water. This is true in the prairie adjacent to the forest, and I'm standing here in the riparian forest. The forest is characterized by a variety of different types of trees that would include things like sweet gum. You'd see live oak in here, water oak, willow oak, probably swamp red oak, and then palmetto, which is our native palm. And it's the little short palms. You'll see some of those if you look over my left shoulder here. So it's been probably, I don't know, 8, maybe 10 days since we last had any measurable rainfall in this area. And yet, again, if you look over my shoulder, you can see that there is some standing water behind me. And that is actually part of that wetland complex. Now, I'm having you read a paper by some colleagues of mine, Andy Sippets with the Texas Parks and Wildlife Department, and John Jacob, who recently retired from the Texas A&M system as part of the Texas Coastal Watershed Program. And so they did a really neat study looking at the importance of these riparian and otherwise what we refer to as isolated wetlands in terms of the volume of water that flows out of these wetlands kind of indirectly and intermittently into more traditional waterways like Armand Bayou, something you could canoe down or take a boat down. And that's important from a habitat protection standpoint and a water quality protection standpoint in the sense that traditional waterways like Armand Bayou are very clearly protected under the Clean Water Act, whereas wetlands that are not traditionally navigable are oftentimes not protected under the Clean Water Act. It's a lot murkier, because we're talking about water. Oh, come on. Anyway, so it's a lot less clear in terms of whether or not wetlands that are not traditionally navigable are protected under the Clean Water Act. And so we're going to read a little bit about how you make that determination and that sort of thing. But I will tell you that a lot of times these types of depressional wetlands are not protected and therefore are sometimes converted into other uses. They might be filled in so people can build houses on them or any number of different things. But they do have a lot of importance, and that's what I want to talk to you a little bit about today. So I'm going to flip the camera around so that you can see a little better, and I think I'm going to put on some mosquito repellent, and then I'll catch up with you here in just a minute. Okay, so turn the camera around, and you were looking at that same wetland complex. There are some little showers going over today, so actually we're having just a really light little rain shower right now. We have a front coming through overnight, and I expect some significant rainfall, so I want to come back out here in a couple days because I want to show you some differences. But for the moment, You can see behind me that there are these depressional areas that have standing water in them. Okay, these are defined as wetlands, and you can see some wetland indicators. For instance, off in the background there, you can see a little palm tree. And let me scoot over here so you can see one up close. This is our native species of palm. This is called dwarf palmetto. The scientific name is Basal minor. And it likes to have its roots wet pretty frequently. So it likes to have very saturated soils and standing water. In general, wherever you see this little palmetto growing, you can be assured that that is very saturated soil and probably has wetland features associated with it. If you're ever buying a property somewhere and you see these trees standing around on the property, be forewarned, okay? Another thing that is a good indicator is, let me zoom in here. If you look on the bottoms of these trees, you can see that there is kind of an algae line or a water line. That shows you how high the water can get in these wetland areas. This is called a watermark. Sometimes you'll see almost a white line on the other side of the tree. You'll see a little bit of a white line there. And again, this is a watermark, and it's indicative of standing water in this shallow depressional area. Now, let me zoom back out. If I pan over this direction, you can see that that area does not have a lot of standing water in it. In fact, there's barely any at all. But you can see there's areas that are just covered in leaves, but there's no grass growing in them. Those are the lowest sections, and those would tend to be filled with water more and more frequently. So the soils are part of the important aspect of these wetlands. You know, our soils here along the coast are very laden with clay, so they have a high component of clay as part of their matrix. Clay is a very fine, small particle that packs together very tightly, so it wants to hold on to water. It absorbs that water into the interstitial spaces and also causes it to back up. That's why we're seeing the standing water on the surface. Again, it's been 8 to 10 days since we've had any measurable rainfall here, and this water has been standing here throughout that period of time. Now, this is really important from a flooding standpoint, for instance, because when it rains, these wetlands will absorb that water and hold on to it so that instead of just running right off into the bayou, running downstream and then backing up downstream and overflowing into neighboring properties where there might be houses or roads or that sort of thing, it's held on to here and it's released very slowly out into Armand Bayou, which helps prevent flooding downstream. While this water is standing here, something that it's doing is something that the wetlands are doing is they are actually helping to clean that water before it runs off into the bayou. So the plants are particularly effective at doing that, but also just the force of gravity is really a factor here. When the water runs through these wetlands as overland flow, so it's coming from other adjacent properties, it has little fine sediments. If you'll remember in a previous class, we had looked at turbidity, the small particles that get stirred up in the water and make it cloudy. Well, when this water comes in here and it sits still like it is now, those particles will slowly settle out to the bottom, and they actually become part of the soil complex. Now, you remember, or should know, that those particles oftentimes have things attached to them. That can be chemical constituents like nitrogen and phosphorus. It can be bacteria. It can be sometimes contaminants. But those settle off and they become part of that complex. Now, the plants that grow here can also then start to ameliorate or kind of fix that water quality. So things like nutrients that would be bound to those little particles can be taken up in the plants and taken out of the water before it then moves further off into Armand Bayou. Now, this water, if it sits here, if we didn't have any rain coming, this water would eventually soak down into those soils, and it actually becomes part of the groundwater. So that cleaning action is really important so that the nutrients and any potential contaminants and that sort of thing doesn't get down into the groundwater. This is actually a primary mechanism. These types of wetlands are really important for recharging groundwater. Since we do have some rain coming through over the next 24 to 48 hours, what's going to happen is these wetlands are going to fill, and then they are going to start to overflow. And when they overflow, that's when they find their way into Armand Bayou. Again, the function of these wetlands, slowing that water flow down and helping clean that water up, is a really important function of these wetlands. And when we convert these, when they're filled in and we build on them or we convert them to some other purpose, we lose those functions. Now, looking at this from an economic standpoint, how much does it cost us for these wetlands to do this job? That's the question. I'm going to say free. And Macros Mac is going to tell you free is a very good price, right? So there's value. We can use the valuation methods that we've learned in class to actually assign a value to the product that these wetlands are producing. All right, so the next thing I want to do is I want to show you where these wetlands actually overflow into Armand Bayou, and I want to talk about it from the standpoint of the paper that I'm going to have you read on the study that my colleagues did here. Okay, so as I'm walking down to where the outfall is, there are a bunch of little pocketed wetlands throughout the complex along the trail here. And so this is one. It's very small, probably only about 15 feet in diameter, but again, it has all of those wetland characteristics. So you can see, watermarks on the trees. You can see the little dwarf palmettos, and there's a little tiny one right in the middle of that little depression. And again, this is just a small depression. It's probably only maybe 4 to 6 inches deep. So there's not, there's really not much there. And in fact, when it's dry over a period of weeks, this wetland may be completely dry on the surface. Now, the soils might still be somewhat moist because they are often in communication with groundwater underneath, and because these are clay-based soils, they're going to hold on to water for quite a while, but there might not be any standing water in this wetland. But you get a little bit of rain like we have coming in here today, these couple little showers, and it doesn't take very much to cause these to get a little bit of standing water in. Again, they're doing the same function. So as you look out over several hundred acres, there's maybe hundreds of these little pockets of wetlands all functioning together, right? So this is all one big system. All one big system, different parts, all functioning together towards a final product of sorts. And in this instance, it has a lot to do with water quality, flooding, and habitat provision. Okay. So as I'm getting really close to where the weir is, where this drains into the bayou, I wanted to show you this complex is what drains into that. And you can see it's fairly extensive. There's more of the dwarf palmetto, there's a whole stand of it back there. You can get a sense of just how many wetlands are present here. It is really extensive, and yet, again, these are the exact type of wetlands that not only are so critical in terms of the water quality and flooding characteristics of our landscape, but also are wetlands that are oftentimes threatened by development or conversion that are lost to the system as a whole. Kind of akin to taking, both the wheel or all the wheels off your car and expecting, then to drive to the grocery store. So I'm here at the end of the line, so to speak, and this is where the wetlands that I've shown you up to this point eventually drain out into Armand Bayou and then find their way out into Clear Lake and then Galveston Bay. So what you're looking at in the screen here, in the middle of the image, you're seeing, looks like a little footpath, right? It's really overgrown, and that's because you don't actually walk on it. This is a very shallow swale, all right, which is a depressional a linear depression. Unlike the ponded round depressions that are the wetlands, this is a linear depression, and it's a low spot in the ground that leads back, and there might be several of them in here. In fact, I know there are. And so where it's washed out there is from where water has flowed through it at different times. In fact, I'm going to zoom down here. You can see how the leaves have kind of been washed. You can see where water's been flowing through there before. And it flows down until it gets to here. All right. Now, this apparatus was detailed in the Sippets and Jacobs paper that I'm having you read. And this is the weir, W-E-I-R, that they discussed. So it's this metal plate, and you can see what it does is it kind of blocks this swale, all right, both directions. It only goes, I'd estimate this is probably 20 feet, this metal plate. And you can see it's got this V-shaped notch in it. And if you look right here, let me zoom in, you can actually see just a little bit of water trickling out of those wetlands from the few showers that we've had today. Now, this is just very light. It's not very much water right now. After we get the big rainstorms overnight and tomorrow, I think this will be flowing a lot more. But in any event, so what happens is all that water flows through here. It goes, and it's kind of creates this pinch point where that V is. So it forces, the weir forces the water to go through that V-shaped notch. And that white pipe on the side, when this is operational, that holds a measuring device that they talk about in the paper that measures the water, the amount of water going through this weir, and they measure over time, right? Because seasonally, these depressional wetlands, forested wetlands, may be dry on the surface in times when we don't have, much rain, and then in the wetter periods, might have a lot of water in them, and the water would be overflowing through this swale, and then it would go through that culvert, because I'm actually standing on a service road here. So you can see where I am here, at the service road, and then it goes across the service road and out through the other side of that culvert and into that swale, which then continues on in all the way down to Armand Bayou, which is about maybe, I don't know, 200 yards from here, somewhere thereabouts. It's not very far. Okay? All right. So, again, the time element of this study is really an interesting and important one, because oftentimes these types of depressional wetlands are excluded from protection under the Clean Water Act because they don't have a constant running connection to a navigable waterway, like Armand Bayou, where you can take a kayak or canoe in it, like we talked about. In fact, oftentimes the little streams or swales, sometimes referred to as ephemeral, meaning intermittent, sometimes they're dry, sometimes they're wet, and so these wetlands can be considered, in some instances, isolated, or at least that's how they're termed. Now, what this study is was aiming to do was to determine, are these in fact isolated, or do they in fact have a significant impact on the water quality in the adjacent waterway, Armand Bayou in this instance. And as you saw, they found that in fact they do have a really important connection to the bayou and have an impact on things like water quality. And so this is why it's really important for decision making to be informed by science, by actual data, measurements, where we are determining, is this in fact something that we need to act on? Is it something that we need to consider when we are looking at how are we going to maintain water quality, habitat, and reduce flooding in an area that depends on that water for much of our economy and is very prone to flooding? Well, it turns out that these forested wetlands that might otherwise be considered isolated are in fact really important in terms of the part that they play in the greater system. And so, when we fail to protect these wetlands from development, it essentially undermines the function of the system as a whole. So, I thought you would enjoy actually getting to see this apparatus from the actual paper, since this study was done locally and I had relatively easy access to it. If I get an opportunity after we get some good rain, I'll come back out here and see if I can get some image images of water actually going through that weir, so you can kind of get a sense of how much water can flow through here at any given time. All right. I want to move on down just a little bit further. I want to show you out in the bayou, and so we'll go from there. So the trees aren't just important when they're alive. Even when they're dead, when they find their way out into the water, they provide structure that is home to a number of different organisms. Here you can see some barnacles actually attached to that, but as this wood decays, it becomes home to a number of different species of invertebrates. If it's sticking up out of the water as snags, it is important roost habitat for birds. And trees that overhang the side of the bayou are important for shading the bayou, which keeps it cooler, which is important for it retaining oxygen in the water, which the fish need. So again, just an awful lot happening here. Okay, everybody, we are at the bayou proper. So this is Armand Bayou, and so I'm on the shoreline, and you can see the bayou is actually quite wide here. Armand Bayou is one of our many area waterways that has suffered from ground subsidence. So we've talked about subsidence before, but you know, Armand Bayou used to be historically much narrower. And if you look at historical aerial imagery, perhaps through Google Earth, you can see, if you go back far enough, that the bayou was only maybe 15 feet wide at the main channel, and much of what's now water was shoreline habitat, much like this emergent wetland that I'm showing you here. So this is primarily Gulf cordgrass. Spartina alterniflora is the scientific name. And it's a wetland, so this is a different type of wetland than the forested wetlands, and it functions differently, so it has a different function. The wetlands I was showing you before were really important, so those forested wetlands are really important for removing nutrients from the water. They're very effective at that. So things like nitrogen and phosphorus, soil particles as well, that turbidity, they're really effective at removing those. They're important for feeding the groundwater, the aquifers underneath the land, which helps prevent subsidence, right? These wetlands, this Gulf cordgrass here right on the bank of the bayou, is more important for providing oxygen down into the sediments, which is a very important part of providing for the food web, because that's where all the little worms and clams and crabs and things burrow down into. But they're also important habitat for fishery species that come in from the Gulf of Mexico into these inland bayous in order to lay their eggs, right, so that they can reproduce. In fact, most commercially fished species need these types of wetlands in order to reproduce. Think about how important that is to our local economy. It's huge, right? So all of this, my point here is that all of this is part of one really large, complex system, and all of the parts have to be present and functional in order for the system to work as it's intended. This includes even animals that live out in the bayou itself. I'm going to share a little footage here before I end this clip of from a kayak trip that I took recently downstream, down this ways a ways, and I'm going to show you some of our native clams, Rangia cuneata, Rangia clams. And these clams filter water. So you'll actually see them doing that process a little bit. But again, all of these are extremely important in terms of eventually providing the water quality that is so important to our habitat and habitat complexes. Oh, looky here. That is an osprey right there. Like he's trying to find a roost. He was hunting a little bit. Okay, well, that was a neat little happenstance. In any event, so all of the different parts, including the clams, the wetlands, the trees, the soils, the organisms that live in the soils and the sediments, all of them function together to provide all of these different services. So, well, I hope you've learned something. I hope this has been enjoyable to you. And if you ever get the opportunity to come out here, I surely hope you will. Maybe I can even get you out here as part of a field trip where we can do some seining and sampling while we're out here. So I will look forward to talking to you soon. Hey everybody, I am back out here at the Armand Bayou Nature Center, and it's about 3 days after our rain event. And the rain event was, not nearly as wet as they predicted, at least not on this side of town. We maybe saw half an inch of rain, maybe a little more. But nonetheless, I wanted to come back out here so you could see what's happening after that rain event. And so, let me zoom in here just a little bit. Here close to the weir, you can see there's still some water running through there. One of the things I'd like you to notice is that the leaf litter that was in the swale, both of them, maybe a little harder to see from here, is a little more cleared out than it was the other day. There is a small amount of water running in there. My guess is that if I were out here when the rain was actually falling that night, overnight, when we got the heaviest rain, my guess is that it was probably maybe 3 inches, maybe 4, flowing through the V in that weir and on its way out. But what I want you to notice is that these wetlands are still releasing water. Now, they were doing so the other day when I was out here as well, to a lesser extent, but they're still releasing water out into Armand Bayou slowly from these prior rain events. Now let's go over to the other side of the service road because I think it's a little clearer to see what's happening. Okay, so I'm on the other side of the service road now, and you're looking at the outfall. So this is this culvert that goes underneath the road. There's a little bit of erosion there, probably from high flow events. One of the unfortunate things about culverts is they concentrate the flow in a very narrow area, and so when you get a lot of water running through there very quickly, it will erode right underneath it, and that's one of the unfortunate features of man-made structures in some instances. But here's what I want to focus on. Let me scroll over here. If you look here, I want you to see that there is still water flowing through this creek very slowly, right out to Armand Bayou. Now, it's not a lot of water, I'll grant you, but we only had half an inch of rain 3 days ago, right? And it's still flowing. Those wetlands are providing ecosystem services in the form of flood control, right? So they're holding onto that water like a sponge and releasing it very slowly. This helps protect downstream areas from flooding. The wetlands are cleaning that water while it's there, taking out nutrients and particulate matter that would make the water turbid. And they're recharging the groundwater, all for free. So there's a lot of value for us as a society to protect these, and that's the value of the Clean Water Act, and why it's important that these wetlands have that type of protection so that we don't convert them to other landforms that would not provide these ecosystem services. So real value here. And I hope you're able to see that, and hope you've enjoyed this little video series out here. I will look forward to talking to you again on another subject soon. All right. I wanted to take a second and stop and get some imagery of this wetland. I shot some video of this the other day prior to the storm event. There's that stand of palmetto back there in the back. And mostly I just wanted to get kind of a before and after. So you can see this is holding a little more water than it was before. Again, we only had about half an inch of rain. But nonetheless, these wetlands over that 3 days have been working with that water, slowly releasing it out into Armand Bayou, cleaning it, recharging the groundwater, all of that. I like this. I like this view because a lot of people, and maybe some of you, would look at this and you would see a big swampy mess. But the fact is that these wetlands are providing ecosystem services that, in some instances, are very easily linked to our local economy, especially when we talk about flood provision and water quality and groundwater recharge. But there are other things that are happening in this system, particularly in the sense of habitat, that may be a little more difficult to link directly to an economic value, but are important to the overall function of the system that provides those values. So something to think about as you look at this as we move forward.